Hi, Dave Littman, Truth in IT. Welcome to today's webcast. Today we are supercharging AI in academia. Today's webcast is sponsored by DDN, and we're talking about how DDN's partnership with Purdue University advances data research. And in just a second, I am going to be handing things over to our panel. Today, we will be led by Mike Matchett. You know Mike. Mike is CEO and Principal Analyst with Small World Big Data. And Mike will be joined by Kurt Cocaine, who is Vice President of Marketing with DDN, and Preston Smith. Preston is Executive Director of the Rosen Center for Advanced Computing at Purdue University. We expect today's event to go probably about 30, 35, maybe 40 minutes. And of course, we will be taking your questions and comments in the chat room. We have staff standing by from Truth in IT to answer any questions you may have about today's video feed or audio or anything like that. We have also staff standing by on LinkedIn Live to help out with any questions there. And of course, we have staff from DDN to answer any questions you may have about today's content. And we are also doing, as you know, an Amazon gift card giveaway. We're going to be giving away 10 Amazon gift cards, or Visa gift cards actually, each valued at $100. And here's how that works. Towards the end of today's event, we will display an image directly over the video feed that looks like this. When you see it, just click on it. It will take you to a page that looks like this. Just hit the enter button. You'll find out immediately whether or not you've won. And whether you have or you haven't, come back. We're running these events all the time. So any questions on that, please just chat those in. But without further ado, let me hand things over to our panel and Mike Matchett. Mike?
Yeah, thanks, Dave. Yeah, super excited today. I've got both Preston and Kurt here. Sorry, Kurt. I'm more excited about Preston today. We're going to talk about what's going on at Purdue in the Advanced Computing Center that you run there, Preston. Let's just start a little bit with that then. Could you just tell us about the scope of this center that you're directing? What do you do at Purdue?
Oh yeah, thank you. So I'm the executive director of the Rosen Center for Advanced Computing. In a general sense, we're the campus high-performance computing provider for Purdue University. We support about 300 computational science research labs from over 65 departments across the university, and that range from everything from mechanical engineering to chemistry to plant sciences to humanities and the business school. And we have users from all three Purdue campuses around the state of Indiana.
Right. So when you say advanced computing, give us an example of some of the kinds of computing you do there. What's sort of the scale and the advanced part of that?
Yeah, sure. Yeah, so naturally, a university like Purdue, Purdue is well known for engineering. Obviously, engineering is Purdue's bread and butter. So the vast majority, about 2/3 of the utilization of high performance computing is from that engineering school. Our largest areas of computationalists are from aeronautical engineering, mechanical engineers, people doing finite element analysis, fluid dynamics, computations for hypersonics, for aviation, for advanced manufacturing, computational chemistry, high energy physics. We have a center here that we operate within the Rosen Center. That's a tier 2 level facility for the Large Hadron Collider on the CMS experiment run out of CERN. So it's very, very data intensive. But then the other half of Purdue, in addition to engineering, is agriculture. So increasingly, agriculture is a very data intensive field as well. We're seeing farmers are using drones for remote sensing, so they need fast data pipes for moving their data to the high performance computing resources, doing image processing, sensor networks with IoT. So things that you never would have guessed 20 years ago that farmers would need to do are now increasingly requiring high performance computing. And we're very happy to help our agricultural researchers apply those technologies to their science.
All right, just one more question before I got something for Kurt. When we talk about high performance computing, traditionally I think of these massively scale out kinds of applications, requiring large clusters, maybe doing simulations, things that have a lot of interconnected to them, a lot of scratch storage needs, things like that. Tell us though, are you seeing a lot of new AI stuff coming along? I think everyone's going to ask that anyway.
Yeah, absolutely. I think what we see, we certainly do see a lot of that traditional HPC modeling and simulation use cases where you need the high speed, low latency interconnects for parallel computing. The CFD people that I spoke to, those are great examples. But we see lots of people who are doing resources that are maybe more embarrassingly parallel in their computations. They run lots and lots of loosely coupled work, which works great on those HPC architectures as well. But yeah, increasingly over the last several years, we're seeing AI is starting to creep in more and more into all sorts of scientific domains. Whereas a few years ago, it was really the computer scientists or maybe the computer vision people that were driving the state of the art in AI. But now our user community is from all over the university. We're seeing people from the humanities area trying to use AI,
Hmm.
with the agriculture, the business school. If there's a scientific domain that we serve, somebody is trying to apply AI to that. One metric that we look at is we looked at our AI compute resource. About a year and a half ago when we ran these numbers, we had, I think, 74 PIs running on that. And then a year later, so at the end of 2023, it was up to over 140. So it doubled in terms of the number of PIs using the central resources to do AI in the span of a year.
All right, so that's really interesting, I think, just to uncover that kernel, because I think of engineering uses, we talked about some of those, you mentioned some of those, but then to think now that supercomputing demand has spread across everybody, it's infiltrated from every across, and your workload sounds like it's doubling in that sense, and I don't even think we have time to talk about scheduling and how people share the resources you have, but how has this really stressed your infrastructure? What do you look at and say like, oh, what are you worried about with all that demand coming in?
Well, certainly with AI, I think one of the things that keeps me awake at night as a resource provider is, of course, we have to meet the demands for GPUs. Like everybody else,
Okay.
everybody wants to get all the GPUs that they can get their hands on. And as a university, Purdue has gone 13 straight years without a tuition increase. So we're very proud of our ability to contain costs in higher ed. But that means that every part of us, including our HPC center, has got to be, fiscally aware and manage our budgets. So finding budgets for buying thousands of H100 GPUs, as an example, just isn't something that we have to do. So we have to be very creative. So finding the resources to get GPUs to meet that AI need is important. And then I'm sure many of the listeners here on your broadcast will recognize the challenges that then come as the second order challenges of buying all those GPUs, as you have to deal with facilities, power, cooling, space, and all the places that you need to put those GPUs into.
All right, I'm just gonna take a break from that
Yeah.
because I definitely want to
Yeah.
dive more into the AI ideas and the GPU needs and how you spread those across things. But Kurt, I want to ask you a little bit about from the DDN perspective. Obviously, you have expertise in providing infrastructure, particularly storage through Exascaler and now Infinia to these places. How are you seeing that develop in the marketplace, and particularly with research centers like the one Preston here is running?
Yeah. So we are definitely encountering the same challenges that Preston mentioned right there off the top, right? The fact that our customers are, constrained in terms of, the number of GPUs they can get and the utilization that they want to get out of those GPUs, coupled with budget constraints, real estate constraints, power constraints that are very real. Right in the Silicon Valley, we see just the ability to build new data center space is allocated out for 3-4 years. So we're not getting additional space to be able to put these GPUs anywhere. And that's true, in lots of geographies. It's not just here in the US, hearing the same things in Europe, if not even a greater challenge. And so those are one of the key things that we're pursuing with our solutions is making sure that those GPUs that are in place are getting maximum utilization. And so we're constantly trying to cut down on the overhead with things like increased write performance so that, times that are spent as unproductive, let's say checkpointing during an operation, right? That's time where the GPU is not computing on, say, a training run, but it's just writing data to disk, we minimize those types of events in terms of time so that the cycles are fully used on those GPUs to do productive computing. Similarly, right, just around packaging, we attempt to fit the most performance into the smallest package, so that most of the data center space can be allocated to this powerful tool, the GPUs. And so you see, I mean, we've gone from needing racks and racks and racks of systems to be able to provide gigabytes or terabytes per second of performance, to being able to do that in just a couple of 2U systems, right? And we're up to now approaching 100 gigabytes per second in a single 2U system, to be able to provide, super efficient footprint within the data center that allows these GPUs access to shared storage that's as good as as if it was local storage.
Yeah, I can almost see the data center, Preston, that you must have there, with sloshing back and forth. Like storage was expanding. There's ever more data. Everyone's bringing in data. I got all this agricultural data and video data and stuff. And then it's like, nope. Now I gotta crunch that back down because the GPUs are coming in this way and taking over floor space this way. How do you stay on top of that battle of where and how much of each resource do you keep on the floor or try to get on the floor?
Yeah, I think that's a great question. One of the things for being a university center is that we don't have the luxury of really having like one consistent workflow that we need to optimize for. We do obviously have a few major ones, but we have to be able to support applications from CFD to bioinformatics and AI on the same system. So a machine has to be able to do everything pretty well. And what we've seen over the last couple of years as both AI and GPUs have become important, or CPU systems have gotten to be so much more dense. 128, 192 core compute nodes are now our norm. We've definitely seen the I/O needs for these systems evolve over time. These rough rules of thumb that we would know that if we're building a system of X size, the storage needs to be of Y parameters have really kind of gone out the window over the last couple of years as core counts have gotten denser and GPUs have gotten in there and the workloads have changed. But we've had to we benefited a lot from those scales and the density that Kurt talked about. Just recently, this last year, on our throughput AI machine, we replaced the storage system underneath it because it was 5 years old or so. And we went from 2 petabytes in a rack and a half to I think 5 petabytes in about a third of a rack. So that increased density and getting more performance was a real win for us, because then that frees up floor space and power and cooling that we then turn right around and use to host more GPUs.
Yeah, it's kind of funny because I didn't think we'd be having a capacity discussion. This is really about performance at some level, but it's fascinating to me. I used to do a lot of capacity planning for data centers. So in performance, let's talk about performance for a bit, and maybe even a little bit about reliability. When you are designing what goes next, the different generations that go in here, how do you just even think of that, since you have such a wide variety of workloads? How do you aim for certain performance points, and how do you think about generations of infrastructure coming through your center?
Generally, the performance point that we optimize is probably for IOPS and capacity, and generally the bandwidth falls out, and at the end of the day, you get enough spindles to get capacity, and then the performance is good for all of the applications that we see. But we see the most demanding applications in terms of storage needs have been bioinformatics, AI training, all of those things that really need to access lots and lots of files very, very rapidly.
Right, and GPUs are just, the applications that use GPUs, I should just clarify, are increasing that demand for both capacity and performance, would you say?
Yeah, certainly both.
Yeah. And let's talk just a little bit about reliability and restart stuff. Do you spend a lot of concerns? I mean, you're not an enterprise, you're not flying airplanes daily or space shuttles in real life and operations, but with so many workloads and so many things going on, it's probably pretty critical that the infrastructure remains available and running to near capacity, near utilization. So how do you approach that at the center?
Yeah, I think your analogy is spot on. We're not doing healthcare. We're not landing people on the moon. So there's no life or death requirements for the machines to be up and running. We aim for probably 96% uptime, one and a half nines, so to speak, um, and we achieve that easily. That said, no scientist likes having the cluster down for days on end, and having their grad students be idle. So we certainly try to be proactive and make sure that the resources is appropriately utilized. Like we don't have a runaway science code driving performance down, or having hardware failures, making the entire resource available unavailable for everybody.
Yeah, I mean, and back to you, Kurt, a little bit, because I think what I would see just standing back, whatever happens in the university space eventually is what's going to, I don't want to say trickle down, but eventually what's going to emerge and flow out into commercial use or enterprise use, or even smaller, right? Just because what they're pioneering very quickly these days drives what happens outside the university, right? It's no longer 20 years later. It's probably like two months later. So what do you guys see?
I think that is one of the major changes that we've seen, is really the demand for this type of computing has exploded in the commercial space, right? Where as before, maybe you had a small HPC team if you were a manufacturer, because you were doing some of the similar work that Preston mentioned around, CFD, or, you were in the defense space. And so, things like hypersonic flight were also something you were researching right alongside the universities. And so we are seeing the demand, because of AI, be much more present, quicker, and so that folks in the enterprise space are adopting this technology just as fast, and right along with the expectation that it's going to operate like their other enterprise computing does. And so things like resilience and availability are really, really important to them. And so that's an area where we're pursuing very heavily as well. And one area where the use of the parallel file system does benefit those customers is the fact that there isn't one connection to the storage, right? It's the storage, all the systems, all the clients know everything about all the data. And so that when you have an individual link that goes down, or even a GPU that fails, which, right, when we're talking about thousands of GPUs, and now in some circumstances, tens of thousands of GPUs, you're going to inevitably have different failures. And so being resilient enough to account for those and keep those systems up is hyper important.
I mean, you get that scale happens, and now every failure just magnifies in impact on there. Tell us a little bit, Preston. Just give us a little bit of an inside the look view of what you're doing at the cutting edge. How are you helping your university and your folks go to that next mile, maybe beyond what folks might normally expect to see?
Yeah, some of the interesting things that our center has been working with researchers around campus for, certainly we're involved in some of the national defense initiatives that Purdue is leader in, doing things with all sorts of aerospace type of research. We do a lot with controlled unclassified information, so that intersection of the defense space with university research. We're increasingly, as a resource provider, we're looking to cloud-like interfaces to things. Like many of us who run HPC centers, we're used to the batch computing paradigm with things like Slurm, running our jobs in batch. But we've been working with a number of researchers to provide composable Kubernetes-based systems that are kind of adjacent to the HPC systems, which opens up all sorts of interesting possibilities for perhaps like stateful databases and portals and inference engines, all of those things that are like that cloud-like experience that people start to see, particularly in the AI world, but leveraging our HPC investment and physically or networkly adjacent to that HPC system. So there's a lot of really interesting opportunities from that composable world.
Yeah, I mean, we know we can go out today and get some AI GPUs as a service from a couple of different providers. Getting HPC as a service is a different animal yet again. So it's kind of interesting that you're sort of pushing those buttons.
But I think that's also another interesting space where I think the commercial world is driving the technology, in that, these cloud-like services are just an expected order of operation now.
Yeah, that interface.
Yeah, exactly. I mean, there is no concept of doing it another way. You don't want to wait weeks to provision things. Your folks on staff want to be able to click a few buttons because they know they can go out and get it other places if it's not on demand. And so we're similarly working in that direction, in that we have our new platform, Infinia, that is really specifically designed to be able to offer those types of features, not just to commercial enterprises, but also to folks who are doing research work at scale.
Yeah, I think on the storage side, that cloud-like interface, I think a very interesting place to explore. We see in HPC like POSIX file systems, and that interface to data is still what I think many research codes look to and what people are used to. But when you look at the cloud world, when you've got object stores, that S3 interface to things, it's really attractive. It's really flexible. It can be really performant. So I think it'll be an interesting time if scientific codes can adapt that directly or abstract it in a way and take advantage of those new types of architecture.
Yeah, it really sounds like your center or your job even is evolving from one of providing some infrastructure for engineering students to play with to being more of an on-demand resource across the entire university for anybody who's going to have applications that need that infrastructure. And it sounds like given the applications you've mentioned already, we talked about AI, we talked about agriculture, we talked about it's going to be every department is going to start coming around and saying, I need this and I need this now, and I don't want to spend 8 months planning for it, right? So Preston, where do you see storage going at the Rosen Center? What would you like to see built out?
Well, I think what I see, the big change and the big opportunities are going to be around that object interface to storage. That I think is going to be an interesting transition in the next couple of years. I think increasingly the IO needs are gonna require ubiquitous flash everywhere. We've traditionally been kind of judicious in putting flash tiers here and there for the right use case, and maybe being cost sensitive on it. But these AI workloads are going to require lots and lots of flash, so that's going to be a different thing to manage. But the other really interesting thing around, I would say this is more of a data question, I guess, than a storage question, is doing all the things around fair data. How do you make the data findable, discoverable, all of those library type of concerns. If there's a data set that a Purdue researcher has generated or has licensed, how do we tell everybody at the university that this is a thing that we have, and if you want to run science against it, here's how you can get to it. Those sorts of questions are also very interesting and maybe a little bit more abstract than the storage problem.
I would think that is exactly what we find out when we talk to customers in the corporate world is, they've got 14 global different divisions. They've licensed data here and there. They don't know what they have. They don't know how to use it. They don't know how to leverage it. And they're probably only looking at 1 or 2 applications, whereas you've got this challenge in spades here. You've got all sorts of things. So, Kurt, I'm going to just ask you about this. I know some of the things you mentioned are some of the things that I've heard you guys talking about you're addressing, but where's that going with DDN?
Yeah, it's for sure a huge challenge, right? Just being able to, discover and manage the data in a centralized way is a huge problem out there today, and more places are choosing different ways to solve for it. But we do see built into the product having things like a database that aids in the tracking and the along with automation as being going a long way towards solving some of these problems, right? So the fact that you have these also distributed sensors out there, Preston mentioned at the beginning, right? I mean, these are huge challenges in terms of, in some cases, they're bringing in really high resolution data, generating a lot of data. And so what do you do with that data that's being generated out there on the edge? And how do you figure out which of this do I need to bring into like a core data center? Which of it just needs to be there for reference? Which of it can I actually dispose of? And how do I make sure that, the thing that I'm going to need in 2 weeks is actually still available and can be brought back quickly? Those are major challenges, but we see what we're basically setting up as a data plane as being a core element of satisfying that need, in that if you have that one plane that is able to manage from edge to center to cloud, then it is touching all of the data. And then you have the database that also features the ability to automate things like data movement. Then you can create the awareness of, okay, what's out there? Where is it? And how do I get it to the place that it needs to be when it needs to be there, and is not subject to all sorts of manual intervention from administrators?
Oh, that's great. So, given where we're at, I could probably start to drill down, and we could talk lots about bits and bytes and bolts and stuff for the next 5 hours. But I think we've covered what we want to talk about today a little bit. But I've got one last question for you, Preston. If you have one piece of advice for someone who is watching us today and said, I'm trying to stay ahead, I want to be on top of things, I want to keep one foot in the future, and looks to you as providing that leadership, what would you tell them?
I'd probably answer that question, maybe without a technical answer. I would advise somebody, particularly if you're building a university-based or even a research lab or corporate, the key thing that you need to be able to convey is the value proposition. This has been one of my own interests, as a scientist myself, is to build awareness for people who are in roles like mine, to be able to talk about these technology needs, not just as a technology need, but as the way that returns value to the organization. If you're in financial services or healthcare, the HPC is a thing that allows your product to be produced or made cheaper or whatever else. In higher ed, the high performance computing and data investment is what allows us to train students. It's what allows us to get research grants. It's what allows our scientists to get publications. So frame your needs in those terms, and then I think you'll be successful in delivering the services that your researcher community needs.
Awesome. And I will just mention that I have a rising senior here at home here who's looking for universities and trying to figure out where to apply to, and I'm sure he's going to be very interested in looking at Purdue, having watched this when it comes out. So thank you very much for that.
The tuition's been frozen for 13 years now.
13 years. Awesome,
Yeah.
President. Kurt, one last thing for you guys. What would you want someone to walk away with if they're looking at this going, I need to find out more information about this. What's going on in this world, and how's it going to affect me?
Yeah, for sure. Interestingly, DDN, we just relaunched actually our website. So we have a brand new set of information out there for people to go explore. So definitely go check that out. Reach out to us. We have a ton of expertise built up over the last few years, assisting folks like Preston, but also helping folks build, commercial resources as well, especially with this explosion in AI. Folks are turning to DDN to be able to manage their at-scale growth. And you see AI consumer after AI consumer, AI clouds, all of these places turning to us to figure out how to manage this really large data problem, and keep it as simple as possible, and with the utilization as high as possible.
Awesome. Thank you guys for being here today. I had a blast. Thank you, Preston. Thank you, Kurt.
Thank you, Mike.
My pleasure.
Great.
And with that, I'm going to turn it back over to Dave. Dave, back to you.
Okay, awesome, Mike. Thank you. Great job, Preston and Kurt. You guys have time for a couple questions?
Love to hang around.
Okay,
Yeah,
all right,
absolutely.
awesome. So this one came in. It has to do with how you guys balance cybersecurity and data sharing. So I guess let me ask that to you first, Preston, then we'll pass it on to Kurt.
Yeah, so yeah, a university like Purdue, cybersecurity is very important. To those ends, we were very excited that within the last couple of months, we were certified ISO 27001. So that's very excited for the university having that baseline cybersecurity configuration. But on our HPC systems, it's important. We like to keep our researchers' data, located only to their lab. We offer a service called Research Data Depot, which allows them to have full control of their data, where they can share it with them and their graduate students. It's closed off from everybody else, and we have tools that allow them to share individual files or directories with their collaborators as they see fit.
Okay, great, awesome, thank you, Preston. Kurt, anything to add there?
Yeah, I think we see more and more organizations who need that type of capability, and we're building that right into our products, right? Both Exascaler and Infinia feature multi-tenancy, and with Infinia, it's actually a first-order development feature. So it's really part of the core of the system so that you can maintain really secure multi-tenant access, so you can have data that's shared widely within the system, and also data that's really, really tightened down, so it only has access to certain folks accessing that system. And that combined with data governance, I think will be the kind of the next level of security features built into the DDN product line.
Okay, awesome. We only have time for one or two more questions, so let me get this one over to you, Preston. How do you manage campus-wide redundancy?
Yeah, that's a great question. So we do this by offering our storage research to researchers in a couple of different tiers. One that's tightly coupled with our HPC system. We address that by, I'll only jokingly say by not addressing it. We optimize those purely for speed. Our Scratch systems on the high performance computing systems, being in the state of Indiana, I always talk about it like it's an Indy car. They're built to go fast, and they might hit the wall, but it's not going to come apart completely. But we do provide other storage systems for the researchers that are much more optimized for the situations where they don't need to worry about the data perhaps getting purged, with multi-site redundancy within the file system, snapshots for data protection, and other tools like that.
Okay, awesome. Okay, last question. Kurt, let me send this over to you. Does DDN offer HPC or storage for HPC as a managed service, or do you enable systems integrators to offer it as a managed service?
We don't directly offer that, but we partner with a lot of the leading, one of the big things right now is interest in GPU systems. And a lot of those GPU cloud vendors are integrating DDN as the back end of their service, just because, again, the utilization is very high with the DDN systems, and the ability to scale those systems as needed to be able to accommodate the interest of their customers is definitely there. So folks like Lambda Labs or Vulture within the US, Scaleway internationally, those folks are all on-demand services that are using DDN on the back end to be able to provide those systems.
Okay, fabulous. That's all the time we have for today. Thank you so much for joining us today. Many thanks to DDN for sponsoring today's event. Without their generous support, we could not have held today's event. Many thanks to Preston Smith with Purdue University, Kurt Cocaine, obviously with DDN. Thank you so much. Mike Matchett, Small World Big Data, thank you again. I'm Dave Littman at Truth in IT. Thank you all for coming. Let's put up the giveaway. Good luck with that, everyone. And we want to wish you all a great day ahead.